Hello and welcome to G-Fun Facts Online. Today we are descending into the dark. We are going to a place where the sun has not shone for 10,000 years, yet life thrives in a silence so profound it feels heavy. We are traveling to the iron heart of Brazil, specifically to the state of Minas Gerais. Beneath the rust-colored soil of this region lies a kingdom of shadows. It is a world carved not by water or wind, as most caves are, but by the claws of giants. This is the story of a ghost living in a haunted house of geological proportions. This is the story of Paleotoca diminas, the blind spider of the extinct Sloth Burrows. Now, before we dive in, you might have heard rumors on the internet about a creature called Pelleoa Dominos. If you have, wipe that name from your memory. It is a phonetic misunderstanding, a corruption of the scientific name. The creature we are discussing is Paleotoca diminas, a name that translates to something quite poetic, the spider of the old house of Minas. To understand this spider, we cannot just look at it under a microscope. We first have to look at its home, because the home itself is a fossil. If you were to walk through the forests of Brazil during the Pleistocene epoch, say 20,000 years ago, you would not be walking alone. You would be in the shadow of the megafauna. This was the era of the giant ground sloths, animals like the lestodon or the glossotherium. These weren't the slow, tree-hugging sloths we know today. These were tanks, some weighed up to 4 tons, and they were master excavators. For decades, geologists in South America found strange tunnels. They were massive, with smooth floors and arched ceilings running for hundreds of feet into the earth. They didn't look like natural caves formed by water-dissolving limestone. They looked engineered. And they were. These are known as Pelleoa burrows. They were dug by giant sloths using claws the size of pickaxes, likely to escape the extreme temperature fluctuations of the Pleistocene climate. Imagine the sheer kinetic energy required to displace 4,000 metric tons of rock and soil to build just one of these dens. It is a staggering architectural feat. But then, the Ice Age ended. The climate shifted, humans arrived, the megafauna vanished, the giant sloths died out, leaving their great underground mansions empty. Or so it seemed. Nature abhors a vacuum. Over millennia, these tunnels were buried, hidden by shifting soils and regrown forests. They became time capsules. But inside, in the absolute darkness, new tenants moved in. This is where our protagonist enters the stage. In the early 2020s, a team of researchers led by arachnologist Igor Szyzaskas was surveying these iron caves in the Iron Quadrangle of Minas Gerais. This area is famous for its immense iron ore deposits, but biologically, it is a treasure chest. Deep inside one of these ancient sloth burrows, in the total absence of light, they found a speck of life, a tiny, pale spider, barely 2 millimeters long. When they brought it back to the lab and looked at it under high magnification, they realized they were looking at something entirely new. In August 2024, they formally described the genus Paleotoca. The name combines paleo, Greek for ancient, and toca, a word derived from the indigenous Tupi language meaning burrow, the old house spider. So what makes this creature so special? It is a masterpiece of what biologists call regressive evolution. When a lineage of animals moves into a cave and stays there for thousands of generations, they undergo profound changes. The most obvious is the loss of eyes. Paleotoca diminas is completely blind. It has no eyes. In the surface world, vision is expensive. It takes a lot of metabolic energy to grow eyes and process visual data. In a world of eternal darkness, eyes are useless. They are actually a liability, a weak point prone to infection. So, over thousands of years, the spider simply deleted the code for eyes from its DNA. It also lost its color. Surface spiders have pigments to protect against UV radiation or to camouflage from predators. In the dark, color is irrelevant. Producing pigment is a waste of energy. So Paleotoca is ghost pale, translucent, stripping away everything that isn't necessary for survival. But it hasn't just lost things. It has gained superpowers of a different kind. If you turn off the lights, you have to sharpen your sense of touch. The legs of Paleotoca diminas are covered in specialized sensory hairs called trichobothria. These aren't just hairs. They are aerodynamic sensors. They are incredibly sensitive to air currents. If a tiny insect moves a few centimeters away, it pushes the air, creating a pressure wave. The spider feels this wave. It essentially hears the world with its legs. It constructs a 3-dimensional map of its surroundings through vibration and air pressure. It is a hunter that never sees its prey, but feels its very existence. This leads us to the ecology of the Pelleoa burrow. How does a spider survive in a hole dug by a creature that's been dead for 10,000 years? The ecosystem inside these burrows is fragile. It relies on organic matter washing in from the surface, or roots penetrating the ceiling. This supports fungi and bacteria, which in turn support tiny creatures like springtails and mites. Paleotoca sits at the top of this micro-food chain. It is the apex predator of the dark, prowling the floor of the sloth burrow, waiting for the erratic vibration of a springtail. It is a case of metabiosis. This is a biological term describing a relationship where one organism depends on the environment created by another, long after the first one is gone. The spider's entire existence depends on the labor of the giant sloth. Without the sloth's digging, there is no cave. Without the cave, there is no stable humidity and temperature. Without that stability, there is no spider. It is a beautiful, haunting connection across time. But there is a modern twist to this story, and it is a critical one. The region where this spider lives, the Iron Quadrangle, is the mining capital of Brazil. The ground these spiders live in is literally made of money. The caves are formed in canga, a hard, iron-rich crust. To get to the high-grade iron ore beneath, mining companies often have to strip away the surface, destroying the caves in the process. Historically, iron caves were seen as less important than limestone caves. They were just holes in the rock. But the discovery of Paleotoca diminas changes the legal landscape. In Brazil, caves are classified by their relevance. If a cave harbors a unique species found nowhere else, a micro-endemic species, it can be classified as maximum relevance. This gives it strict legal protection. This tiny 2mm blind spider is effectively a guardian of the burrow. Its existence forces us to pause. It transforms a hole in the ground into a biological sanctuary. It reminds us that biodiversity isn't just about tigers and whales. It's about the microscopic history written in the DNA of creatures we rarely see. The description of Paleotoca diminas is a triumph of taxonomy. It involves crawling through claustrophobic tunnels, avoiding kissing bugs, sorting through thousands of samples, and analyzing the microscopic geometry of reproductive organs to prove that this is indeed a new genus. It is hard, unglamorous science, but it yields results that rewrite our understanding of the world. We are also seeing a golden age of cave spider discovery in Brazil. You might have heard of other species named after pop culture figures. There are spiders in the region named Ocarocera aragog, after Harry Potter's Aragog, or Ocarocera varus, after the spider from Game of Thrones. These names capture the public imagination, but Paleotoca diminas captures something deeper, the geological history of the continent. It stands as a testament to the resilience of life. Think about it. The giant sloth was a titan. It shook the earth when it walked. It is gone. The spider, delicate, blind, and silent, remains. It has inherited the empire of the giants. As we conclude this deep dive, consider the fragility of this existence. These spiders are likely restricted to very specific cave systems. A single mining blast could wipe the entire species off the face of the earth. We are racing against time to catalog this biodiversity before it is lost to industrial progress. Paleotoca diminas is more than just a bug. It is a living memory of the Pleistocene. It is a survivor living in the ruins of a lost world, navigating the dark with a grace we can barely comprehend. So the next time you think of the ground beneath your feet, remember that it might not be solid. It might be hollow, carved by ancient claws, and inhabited by the ghosts of the old house. Thank you for listening to G Fun Facts Online. If you enjoyed this journey into the dark, keep exploring with us next time.